Okay. Hello, everyone. I think we should. We should start. Yep, we're just waiting a couple of minutes for people to join the webinar. Well, welcome everybody for joining us today. We're really excited about this new release, and we're really happy that you've all decided to join us for this release webinar. I'm going to give you a very brief intro to what's going to be the plan for today, and then the rest of my colleagues will get into more detail about the new features in this release, in this new version, and we'll also talk about we'll have a practical demo about how this new technology works, and some more details about the services we have for managing clouds. Well, my name is Alberto. I'm the open source community manager at OpenNebula. Today I'm going to be joined by Tino Vazquez, our lead cloud engineer and our engineering manager, and also by Marco, our cloud technical evangelist. I'm very sure you've seen him around in presentations and screencasts. And then Michael, our customer success manager. He'll get into more details about, as I said, the managed cloud services we put in place. So very quickly, the program for today, as I said, an in-depth exploration of the new features in this version. We're very excited about this release. And, some of you might be new to OpenNebula, but for those of you who've been using our technology for a longer period of time, this release is actually a turning point in the way we embrace a number of new technologies we were focusing our efforts on, mainly edge computing. But as you'll see, our vision and our understanding of edge computing is not something esoteric as you come across in some articles and some talks. So it's something very practical for us. And for us, it means also a new approach to hybrid cloud computing. So something that can actually help organizations to create an abstraction layer on top of all the resources they need, independently of whether they are in a public cloud or whether they are in a far edge resource, and maybe at someone's home or at some device. For ultra low latency applications, for instance. So as you'll see, we have a lot of interesting things to talk about today. Tina will get into the technical details of the new release and the new technologies and the new tools you come across in the new version. Marco is going to show some of the applications of some of these main technologies, basically the automatic provision of resources in AWS and Equinix Metal, and how we can use now OpenNebula to deploy automatically on these resources, application containers, but also Kubernetes clusters. In this case, he'll be using K3s. So as you know, it's a CNCF project, a lightweight Kubernetes application that's especially suitable for the edge. It's been contributed by Ranger Labs to the CNCF some months ago, and we find it very, very interesting for our applications. And then finally, Michael will provide an explanation of the new services we have attached to our Enterprise Edition, the Enterprise Edition that we launched last year. Now it comes also with the possibility of OpenNebula systems providing managed services for corporate users. And then we'll have at the end a questions and answers session. I guess, the whole session will last for around 1 hour or so. What I'll ask you is, for the questions, it's better, you can obviously use the chat whenever you want. We'll collect all the questions via chat. If you could write them down towards the end of the webinar, that helps us to organize our replies. And then each of the speakers will have a number of rounds and trying to answer all your questions, but that will be at the end of the webinar. So collect your questions, write them down towards the end of the session, and then we'll do a number of rounds for trying to answer all of them. Okay. So Today's webinar is part, as most of you already know, probably is part of a number of activities we do for our community and with our community. That's webinars like this one and other webinars we've been running over the past months. Obviously, virtual events since the outbreak of the pandemic. We've got our annual conference as well, which we're now redefining for the final dates. We'll announce that in a few days' time. We participate in a number of technological events as well. We've got a champion program, and I know some of you are actually members of this program. And we're also happy to have here a number of partners joining our webinar today. So just an invitation for you to keep up to date with keep track of all the events we organize on social media and our newsletter, and join us in future occasions as well. And last but not least, part of the technologies you'll see today, part of the new features you'll see today have been developed thanks to and with the support of the European Commission Horizon 2020 program. So it's actually been a great support for us to be able to develop this transformation for turning OpenNebula into a really powerful open source edge computing platform as well. So yeah, so from here, big thanks to the European Commission for that support. Yeah, I'll leave you now with my colleague, Tino. Go for it, Tino.
Thanks a lot, Alberto. Let me try and share my screen. Okay. Okay, so well, first, thanks everyone for attending the webinar. As Alberto said, we believe OpenNebula 6.0 it's a turning point in the OpenNebula release series. We have introduced great number of features. We think that well, the approach that we follow for the edge and also the ability to create on-demand OpenNebula clusters in basically different types of infrastructures. It's going to be a great addition to OpenNebula. So let's start with, for those of you that don't know what OpenNebula is, or you have known OpenNebula just recently. So OpenNebula it's a cloud management platform. It's an open source management platform that lets you create enterprise clouds to run different types of workloads, okay? And doing so in different types of infrastructures as well. Can be run in your core data center, your premises, but you can, OpenNebula offers you the flexibility to dynamically increase the capacity of your cloud using resources from public and edge cloud providers. So you can deliver your applications, any kind of applications, really, virtual machines or containers or even Kubernetes clusters, as in the best location possible. Okay, so if you are concerned about low latency, for instance, you can choose the edge. If you have enough capacity, you can choose on-prem. And if you want to, attend some peak demands, you make use of the public cloud, and you can do all that without really changing the characteristics of your workload. So you will be creating OpenNebula clusters, and they will be able to run the same workloads that you run on your premises without making any change to it, which we believe is really powerful. Okay, so having said that, well, OpenNebula being a tool that lets you increase the capacity of your enterprise cloud using different cloud providers, We claim that you can avoid vendor locking. Also, we support different kinds of hypervisors. We always have in mind simplicity for our design, feature design. So OpenNebula features an architecture that minimizes complexity, also reduces resource consumption, and it's a piece of software that lets you administrate it without huge operating costs. Okay, a bit more under the hood, OpenNebula is able to run all these different workloads by using different hypervisor technologies. So more traditionally, you can run virtual machines on proprietary hypervisors like VMware, but also in KVM. You can run micro VMs in Firecracker, where you can also make a one-to-one relationship with containers. So you can run containers from Docker Hub, for instance, inside these micro VMs. And you can also run system containers using LXC. Okay, and this is offered seamlessly to the end user by OpenNebula through a graphical user interface, and you are also able to plug in third-party tools to manage your virtual infrastructure, such as Terraform or Ansible, and you can run Kubernetes workloads by deploying Kubernetes clusters as well. So just briefly over the main highlights of the software, that it lets you create a multi-tenancy environment where different groups of users can use the cloud or a subset of the cloud without interfering with other groups, so in an isolated fashion. Your end users can consume the services for using a self-service portal, simplified point-and-click portal. You can not only run containers or VMs individually, but you can also group them into multi-tier applications and apply elasticity rules over them. For reliability of the workload, we provide high availability, not just of the controller of OpenNebula, but also of the nodes, and hence the virtual machines that can be spawned in case of a node crash automatically. You can also federate different OpenNebula instances to create aggregated cloud, such as you can find in Amazon EC2 with the different availability zones. And well, you have the ability to increase the capacity of your on-prem cloud using different public cloud providers. So it's also a multi-cloud tool. And as we said before, you can run different types of workloads like virtual machine and containers. Okay, so yeah, OpenNebula 6.0 Mutara was released last week. So let's go and see some of the main features that we added in this release. So let's start with one of the most interesting, without a doubt, and it's this ability to create clusters as a service in OpenNebula. So with this ability, you can even create a cloud using OpenNebula without owning any hardware. You can launch a front end in any public cloud provider or in your data center, if you choose so. And then increase the capacity of your OpenNebula cloud by requesting OpenNebula, or rather requesting resources from OpenNebula, which will be configured and added as OpenNebula as a regular OpenNebula cluster, okay? So this lets you create an enterprise cloud using resources from multiple public cloud providers. So you can choose to build OpenNebula with resources from your core data center, increase the capacity using public cloud providers, using resources in the public edge or even in mobile edge. And you can even have this concept of on-premise edge controlled by OpenNebula. It would be something similar of what Azure Stack or Amazon Outpost offers, okay? And the important bit is that this is a uniform layer where you can run your workloads without changing them. So you have your virtual machines, your containers, your Kubernetes clusters, and they can run seamlessly in any of these OpenNebula clusters, regardless of where they are placed. Okay. Oops, sorry. Okay, so in order to build these OpenNebula clusters as a service functionality, we had to define a lightweight architecture for these clusters, and we came up with this edge cloud architecture, which is a type of hyperconvergent architecture that it's aimed to be lightweight, but also powerful enough to run any workload with optimal performance, because it always uses the best placed storage backend, which in most cases is the hard disks of the servers where the VMs are running, okay? This is a layout of the networking of the edge cluster. So as you see, you can have some private networks inside the hosts or between different hosts, so applications and pods can communicate. And then we have this storage network. This is a private OpenNebula network, and of course the management network and the public network. Okay, so with this networking, OpenNebula is able to control and to control the physical hosts and also to launch workloads on top of these physical hosts, again, regardless of where these OpenNebula clusters are placed. Okay, so regarding application containers, you don't really need a Kubernetes cluster to run your container workloads on OpenNebula. You can rely on the integrations that we have with Docker Hub and the ability to run these containers in Firecracker micro VMs, which doesn't really have any performance penalty, but offers increased security for your workload. In case you need Kubernetes, we also support the ability to deploy and manage Kubernetes clusters, either with K8, with the regular Kubernetes or with K3s. And obviously you can also have upper layers for these Kubernetes clusters, like for instance, Rancher. Okay, in order to deliver this, this ability to create clusters as a service in OpenNebula, this automatic provisioning of clusters, we've created a new web interface. So this is a web interface that is separated from Sandstone. This is intended only for admins that want to increase or decrease the size of their OpenNebula cloud, enterprise cloud. They can choose to do so using different public cloud providers. So this is the first release with this ability. So we focused on Amazon AWS and also on Equinix. So you have those drivers available in OpenNebula 6.0, and we are already working on more drivers to be able to also have OpenNebula clusters in Azure and Google Cloud. Those would be the ones that will come next. And then we have plans for many other public cloud providers. So we want to build a catalog so our OpenNebula users are able to increase the capacity of the cloud using all the possible choices of public cloud providers or tools that make sense. So with this tool, you are able to create this concept of providers, which are basically a representation of a public cloud with your credentials. And then you have the ability to create provisions on these providers, which are basically OpenNebula clusters with potentially different hypervisors like KVM or Firecracker. Okay. Also, another improvements are related to OneFlow. So OneFlow, it's the OpenNebula component that lets you manage multi-tier applications. So applications composed of different virtual machines or different containers, or even a mix between virtual machines and containers. And you can do so also applying elasticity rules using hypervisor metrics or application metrics. We've been improving OneFlow mostly behind the scenes. So it's not something that you will see immediately in OpenNebula 6.0, but we have fine-tuned the performance and also solved some quirks and in general improve the user experience by adding some small missing functionality that the community were requesting. Okay, this is also a long overdue feature in OpenNebula, so the ability to define a backup policy for your virtual machines. How this will work behind the scenes is that your virtual machine disks and also your virtual machine metadata will be saved onto a private marketplace. So as you may know, you can build private marketplaces based on either an HTTP backend or even S3. So being that an S3 provided by a Ceph cluster or Amazon S3. So you can make backups of your VMs in these different storage backends, ideally outside of your main data center. And you have the ability to obviously also restore those backups in case of a disaster. Okay, and then we've been busy also with some other stuff. Okay, so providing support for the latest version of vSphere, so vSphere 7. This also motivated the addition of the virtual machine, the VMware Remote Console, which is the native way of VMware to provide console access to VMs. This was accelerated because in vSphere 7, you don't have VNC support anymore to access your VM. So now you can use VMRC integrated in Sandstone for that. Related to that, we also added support for Guacamole. So if you used all older versions of OpenNebula, you noticed that we were using a Python proxy called NoVNC to proxy the console access. But now we have added also the possibility to use Guacamole, which provides enhanced experience in VNC and also adds the possibility to, within Sandstone, activate SSH and RTP connections to your VM. So, okay, also, we added new drivers for LXC containers, system containers, some extra functionality for KVM, which is always nice. And also, and this is a kind of a technology preview, but you are also able to deploy OpenNebula within containers. So containers everywhere. Okay, so if you find this interesting, you can try out 6.0, we think, very easily. If you are using KVM, you can try our Mini1 tool. If you're using VMware, you can download an OVA file. It's called V1 Cloud that has OpenNebula 6 pre-installed. So you can do that in in a matter of minutes. So if you are ready to try out your OpenNebula 6.0, you can start deploying OpenNebula clusters in public or edge cloud providers. Okay, and you can start deploying different kind of workloads on these newly created OpenNebula clusters. So all this information, it's available. You can access it through this landing page, but also in the official OpenNebula documentation. And it's part of a new section that it's the quick start guide that will guide you step by step. So it's a great place to start if you don't have any experience with OpenNebula. Okay, so I leave you also with some additional resources. So these are links to, introduction videos and also white papers defining or stating the capabilities and functionality of OpenNebula. Some nice demos like the one that Marco is going to provide now, but with some other use cases. So yeah, you have here some links to get you started in this new version of OpenNebula. Okay, so I think it's time for a poll, right, Roberto?
Yes, we're going to launch a small poll just to understand where the audience a bit better today.
Okay.
Okay, let's see. Okay, we'll have a break of 1 minute or so for you for those of you who want to answer these questions, and then we'll go on with the demo. Okay, I think we're done. Yes. Share the results. Okay, great. Well, thank you all for answering these. And Marco, the floor is yours.
Okay, thanks, Alberto. Okay, so I will talk about how to deploy Kubernetes clusters. We are going to use a K3S, that is a distribution of Kubernetes, a lightweight, that is ideal for edge deployments. So now it's official CNCF sandbox project, and is just a single binary, so it's less than 40 megabytes. So you can really fast provision, and also there are minimal to no S dependencies. The architecture of K3S is based on two components mainly. So you have a K3S server that manages the clusters, and then you have K3S agents, that are the worker nodes to where you can deploy your pods and so on. Okay, let me show you first how what I'm going to show as a demonstration of the latest feature of OpenNebula in this the latest release. And so we are starting from an OpenNebula deployment with just the front end, so without any resources. And then we are going first to deploy resources on a public cloud. So at the moment, with the new using FireEdge, we can add the resources, and so we can define and provision clusters, OpenNebula clusters, on AWS and Equinix Metal. And so what we are going to do is how to automate this provisioning by using FireEdge, and so deploying edge clusters on these two cloud providers. After that, when we have defined these clusters, what we can do is that with this integration that we have now with the marketplace, with the Docker Hub, we can deploy applications, containers. In this case, we are going to deploy K3S clusters by considering an appliance that we released for K3S. So it's based on as a service, a one-flow service. So we can access the marketplace and we can import this appliance, and then we can deploy the applications on these clusters that we have defined on the public cloud, okay, on AWS and Equinix Metal. Okay, let me start the demo that I just recorded before the webinar. So here you can see I don't know if the resolution is okay. So here you can see the Sandstone graphical user interface. As you can see, there are no hosts nor virtual machine and so on. So now let's go on the user interface of FireEdge. So here, this is the dashboard. And here what we have to do, first we have to define the providers. I've already defined one for AWS London. And now I'm going to show how to define a new provider, for example, for Packet. So we can choose between Metal and Virtual. I'm going to use bare Metal because I'm going to use as a technology to deploy K3S cluster, a Firecracker. And then I choose, for example, Amsterdam as a facility for Packet. And in order to configure the connection to this provider, I need the project ID. So this is from the console of Equinix. So you just have to copy your project ID and then an API token that I generated for the demo. Okay, so then you just put the token and the project ID, and then you configure this provider for Equinix Metal for the Amsterdam facility. Okay, now we have two providers, one for Packet and another for AWS. So what we can do is now provision clusters on this provider. So, so in order to do this, what we have to do is, again, select the type of providers that we would like to use, in this case, the Metal Packet, and we select the template for the Packet cluster. Then here we can select the Amsterdam provider. Here you can put the name and the description of the cluster, and now you can configure some inputs for your provisioning, for example, the number of hosts, the number of AP, for example, in this case, I changed to 4. The virtualization technologies. So in case of bare metal, we can deploy KVM, Firecracker. In this case, I'm using Firecracker as an hypervisor technologies for the cluster. So what happens now is that one provision use mainly two technologies, is two steps. One is based on Terraform. So we are going to use Terraform to create resources on the public cloud, and then we are going to use Ansible to configure those resources as an OpenNebula clusters. So in the demo, I'm showing also how to deploy a cluster also on AWS by selecting always bare metal and AWS as a provider. Usually the time that it takes depends on the provider, the public cloud provider. So usually takes from 5 to 10 minutes in order to provision resources on the cloud provider. Also in this case, I'm using Firecracker. In this case, the The instance type depends on the instance type of the AWS, and I selected the i3 metal instance. This will take, as I said, 5–10 minutes, and as I said, it depends on the cloud provider. Now I will go fast forward in the demo, and let's see if okay. So once the cluster have been provisioned, you can see here that there are 2 clusters defined, and we can check for example, in this case, the project on Equinix that has a new host provisioned. And also we can check from Sunstone. We are going on infrastructure cluster. We can see the 2 clusters that now are included. So for example, for the packet cluster, we can check the hosts, the virtual networks that has been defined in the data store. For the virtual networks, we have a public network, so with public IP, and then the data store for a system, for the VM, for the images and files. And the same also for AWS. You can see that now there is an host, a public network, and also the data store. Okay, so when we have provisioned resources, now we can deploy K3S. First of all, we'll go on the applications from the marketplace, and then we can select the K3S service for Firecracker. I'm going to select the data store, in this case, the default data store that is in common with the 2 clusters. And I'm going to import the image for K3S that is the binary for K3S. And also by importing the appliance, also 2 templates will be created, one for the service, OneFlow, and one for the virtual machine that is used by OneFlow. Another thing is that for Firecracker, you need a kernel in order to boot the micro VM. So we have released an update of the kernel for Firecracker that works with the K3S. So you have to select the kernel 4.19. And then you have to import in the files data store in order to import the kernel. So what is required to the user at the moment that we need, the user has to modify the virtual machine template. So you have to click on the virtual machine template, update, and then you have to select the kernel that we have just imported in the OS CPU section in the kernel tab. You select the kernel, and then you can update the VM template. So that's required to the user. Once you do that, we can deploy a service. In the service, we have defined, as I said, K3S as 2 components, the server and the agent. As you can see, the agent as parent the server because it will be deployed after the server is deployed and ready. And so let's now create a service. So we can select the service K3S. Here, for example, we can deploy on the packet cluster as an input. You have this cluster name. You just put the name of the cluster that you have provisioned. You can also change the K3S version. In this case, it will download this release, the 19. You have also some option to disable or enable the DNS or the ingress, the load balancer. And also you can change also the backend of FLAN, for example, using VXLAN in this case. And now once the service is created, it will deploy first the server, as I said, this component. So now this is going to be deployed on packet cluster. That's the input for the cluster name. And so it will deploy first the server. And after the server the start script of the server is going to be to update the VM state. So the VM is ready once it will install the server. We can do the same also for AWS. So in this case, we just put as an input the AWS cluster name, and we can keep the same option, and we can create the other cluster. So now the K3S has been deploying one on packet and the other one on the AWS cluster. Okay. You see the agent is still not starting because maybe the server is setting up the K3S server. Okay, once is ready, the agent will be deployed also for the K3S service. Now let's see, the server has 2 IP. The bold one is the public IP of the micro VM. So first thing that you have to do, you have to copy the configuration file if you want to use kubectl, for example, from the micro VM, and you can copy on your kubeconfig. And then you have to change the local host with the public IP of the micro VM. And here we can check the nodes that are in this. As you can see, there is the server. The agent is still not ready. It will be ready in a few seconds. And once the nodes are ready, for example, we can deploy an application. So for example, here I create a deployment based on Nginx. And then we can check for the deployment. And here you can see that it has been deployed, and then we can check for the pod of the deployment. So it's still creating the container since it's pulling the image of Nginx, and then after the image is pulled, it will start the container. In order to access the application, K3S has a load balancer, so you can expose the deployment by using, for example, in this case, the port 8080. Take into account that when we deploy on the edge, we have 2 IP. So the IP of the VM is a private IP, so you have to check which is the public IP of that node. In this case, this is the public IP in bold, and then we can use that to access the application on the port 8080. So and in this case, we have Nginx available. Okay. So this was the demo. I think that this is is okay. So, Michael, you can.
Yeah, I think that was great. Yeah, thank you, Marco. Yeah.
Perfect. Right, I will take over sharing the screen here. Like, as Alberto pointed out, I'm Michael Abdu. I am the customer success manager here at OpenNebula. I think now that you've gotten really a good look into the OpenNebula software, and particularly some of the capabilities and you know, our focus with this OpenNebula 6.0 release, I just wanted to take a few minutes to kind of provide you a quick overview of our company, of who we are and what we offer. Okay. So here at OpenNebula Systems, we are essentially an open source company. The OpenNebula project began back in 2005. And you know, since then, we've really been dedicated to the project in developing open source software, really addressing the needs of our users, our customers, and our partners, and really trying to build the best enterprise cloud open source solution. So on top of that, we also provide enterprise support, professional services, and even now managed cloud services for customers who are interested. Our headquarters are in Madrid, Spain, but we have offices in the US as well as the Czech Republic. And here you can just take a look. We've just kind of pointed out we're active participants and partners within the several Linux Foundation organizations and consortiums. So this here is a slide to provide a little bit of insight into the broad usage of OpenNebula. You know, right now there are over 5,000 active clouds deployed. As a measure of scalability, you could take a look here and see, you know, the largest deployment of which we're, you know, informed of, you know, is essentially running on 16 different data centers across 300,000 different cores. And then down below here, I think what I wanted to kind of show here is, OpenNebula is really an industry agnostic software. So what you see here is kind of the broad spectrum of organizations, users, customers of ours who have been using OpenNebula. I think it's kind of a testament to the fact that this is a product that's enterprise and production ready. Okay, so as I pointed out, first and foremost, we're providing open source, an open source solution. But in addition to that, in terms of value that we're adding to the market, I think the key to what we offer is really our OpenNebula subscription. Okay, it's really the key to ensuring that your OpenNebula solutions are braced and buttressed with enterprise tools and support. So really, our subscription it provides many benefits. The first is one in providing access to our enterprise edition of the software. And this enterprise edition is really a more hardened version of the software. It's been repeatedly tested and more hardened. We're providing regular software patches, bug fixes, minor enhancements, and subscribers have access to those. I pointed out here that as a subscriber, you also have access to LTS releases. Our previous version, 5.12, was our first long-term supported release. So at this point in time, for subscribers, there are two versions that are officially supported. The active current 6.0, but we also have 5.12, which is going to continue to be supported pretty much through 2022. Okay. Our subscriptions also, at the base of it, provide SLA-based support, for providing support from our support and engineering teams, either on a 9-to-5 business hour basis or 24/7. They also provide access to tools, to our knowledge base, right, which has how-to video guides, best practice documents, as well as detailed use cases made available. And then as a subscriber, you have access to several professional services that our team offers, including cloud deployment service, upgrade services. We provide training, consulting and engineering, and now our managed cloud services. And this is I think here with OpenNebula 6.0, I think this is something we announced a few months ago, but I think now with OpenNebula 6.0 and the edge cloud architecture really available in its complete form, this is a service that we're providing that essentially augments the OpenNebula subscription. So you can essentially hand over the keys to us, and we will provide, we will handle the management, the maintenance, and the upgrades of your OpenNebula solution. We carry out periodic exercises of capacity planning, handle tuning, as well as provide, the continuous monitoring for the availability of your cloud service, all based on an uptime service level. Okay, so this managed cloud services is available for those who are essentially running our edge cloud architecture, OpenNebula deployments. Okay, and as I pointed out, it is really an extension to one's OpenNebula subscription. So with that, I think that's the end of the presentation here. If you guys have any questions, obviously I think we're going to jump into our Q&A. You can ask them here, but also you can reach out to me directly after after the webinar, and we can get into details about our offerings as well. All right, I'm going to hand this back to you, Alberto.
Great, thank you, Michael. Yep. So there's already a couple of questions on the chat. I know, Tina, maybe you want to start with those.
Yeah, sure. Okay, so the first one I see is Luis Sousa is asking if can I use OpenNebula to create, run containers and Kubernetes clusters on VMware? How? Okay, so the answer to this is that this is possible. It's not something that we have focused extensively. So we focused on deploying Kubernetes on open source hypervisors, but it's something that it's also possible, because basically what you do is you deploy virtual machines in VMware, and you run the Kubernetes cluster inside. So pods are basically jails in these virtual machines. So you can make it work that way. If you want to exclusively run Kubernetes clusters in VMware, and that's your only concern, you don't need multi-tenancy, maybe you can check the specific VMware projects for that, like Tenso, I think it's called. Okay, so next question by Stefan Ibet. Is it possible or planned in the future to provision dedicated hardware servers placed at the customer sites with one provision to manage them with the OpenNebula frontend running in my data center? Yes, it's not currently there yet, but it's something that we are currently working on, and probably will be available in the next maintenance release of 6.0. So 6.01 will have a new type of provision that will be called, I think, on-prem, and will let you do exactly this. Okay, next question is Carlos Cesario. It's asking if we have any document, whoops, sorry, lost, okay, about deploy, run OpenNebula with KVM using Firecrack. Okay, that's Fiber Channel, probably SAN storage. I tried it time ago without success, because it seemed there is needed any special config type when using SAN storages with Firecrack, Fiber Channel connection. So yes, the way we have to address this storage infrastructure is through our LVM drivers. So it's possible if you and the documentation for that is the LVM documentation in the storage section of the OpenNebula public documentation. But if you are struggling to make this run, just please contact us, and we have an engineering team that will be more than happy to help you to build that in your infrastructure. Okay, then we have first last asking if can you talk about the default recommended storage for OpenNebula? What is common amongst your customers? Ceph, GlusterFS? Okay, so yeah, we have
that's an interesting one.
It is actually. So yeah, we have a wide range of customized clusters among our customers. So Ceph, it's probably one of the most widely used, followed by proprietary solutions like Storepool. And we also have many customers using storage solutions by Limbit. Also, any distributed file system like Cluster or NFS is also possible, even backed by a NetApp cabin. But with OpenNebula 6.0, we have this new edge cluster with this hyperconverged special type of data store, of SSH data store, but with some extra functionality to improve performance. And this is our default recommended storage for OpenNebula at the moment. Okay, next one.
Maybe Tina, we could mention. I mean, there are some resources online for. I mean, we've run some webinars with Storepool and with Limbit, and there's actually a webinar, well, a tech day, a couple of tech days actually next week with Limbit. So if you have some interest in that particular technology, that feel free to join. We'll be joining them. And explain more details about storage and our integration with Limbit.
Yeah, indeed. Yeah, thanks, Alberto.
That's next week. So.
Okay, next question that I see, it's Manuel Henk. It has two questions actually. It's something planned in the direction of auto scaling. I'm not sure if this refers to the ability to, apply elasticity rules to existing virtual workload. That's something that we have with OneFlow. I think it's pretty much covered. If you are talking about auto scaling, you're automatically scaling the infrastructure by creating new OpenNebula clusters. It's an interesting question. And the answer is, at the moment, we don't have anything planned. Is it possible to migrate workloads between clusters? If the clusters are homogeneous, it could be, but it's not something that it's directly supported or recommended, especially if these clusters are different public cloud providers. So to be on the safe side, I will answer no to this question. It's IPv6 only environment supported? It is, yes. Another question from first last is, for Kubernetes support, do you recommend deploying one large VM per node or several smaller VMs per node? Example, one Firecracker VM per container. So the answer to this, it depends. We offer flexibility on this. So you have to try to make a trade-off between performance, easiness of management. We don't have a clear recommendation for that. It depends on your use case. We'll have to investigate that first. Okay, so Vladimir Lu asks if OpenNebula has provider drivers to provision infrastructure on-prem bare metal. Okay, so I think this has been already answered. At the moment we don't, but in the next point release, 2 to 4 weeks time, that will be available. And the last question I see in the chat, Dimitrios Thotos is asking if can OpenNebula combine 2 different vCenter on-premise instances with different resources each into one cluster that can be managed only by OpenNebula. 2 different vCenter on-premise instances with different resources each into one cluster. No, so this OpenNebula will treat clusters from each of these vCenter instances as OpenNebula hosts, but you won't be able to combine them or aggregate them. So OpenNebula aggregates all the ESX that are belonging to the same vCenter cluster. That's the unit that you can manage from OpenNebula, and you cannot split it nor combine it with others. Is the new backup functionality supported on LVM over Fiber Channel? Yes, so backup functionality is supported across all the combinations, supported platforms and data center components supported by OpenNebula. Okay, I don't see any more questions. If there are more questions,
well, I have one question actually, Tina.
Oh yeah, okay.
Just wondering if you could explain a bit more about the. I mean, you know, there are actually now two models, right? The someone who's got an instance of OpenNebula front end and wants to consume resources from third-party providers, from cloud or public cloud or edge providers. But then there's also the other model, right? That's linked with the bare metal. I mean, with the what we understand of the on-premise edge, right? Just some company that wants to have some resources, some hardware resources on some premises, and want to use OpenNebula to give access to their customers to these resources, right?
Mm-hmm.
So is that something we how are we planning to improve that kind of second use case, for instance?
So you mean when you have an OpenNebula instance and you want to offer those resources to other people?
Yeah, for organizations that want to become edge providers to the customers. So using OpenNebula's multi-tenancy capabilities to offer edge resources to the customers. So that's actually a quite interesting use case, right? That's now available on OpenNebula 6.0.
Yeah, but I'm afraid I don't really understand the question. So
no,
maybe you have an answer.
If we have any plans for making that more easy for companies or to ease that kind of applications in the future for companies that want to use OpenNebula to offer to their own customers new edge resources that they deploy on a stadium or on particular houses or other places. So once they have the infrastructure, and think about these the projects that are now being developed and designed for offering a large number of edge resources. But then companies will need a tool for offering these edge resources to their customers. So I guess now with the changes we're doing, that's actually something we can do, right?
Absolutely, yeah. I think this model it's been presented in OpenNebula 6.0. It can be used certainly to aggregate these different edge resources and resell them or present them to end users using a uniform layer. So yeah, I believe that that's more or less covered, and we are working to improve that use case, definitely.
Mm-hmm.
Okay.
There's another question there in the chat.
You talk about the network concept. So Mark Snyder asking if about the network concept, if using two different clouds in two different locations, so each VM can reach each VM, depending if it's running in the same cloud or not. So no, so we don't provide at the moment any way to build, private LANs between different public cloud providers. So at the moment, the model relies on public IPs, and we leave that to application layer to build any kind of VPN, IPsec, whatever. But we don't provide that at the infrastructure layer at the moment between different public cloud providers. Okay, Bernard Snyder asks, is because the HTML5 VMRC in VMware does not recognize the keyboard layout correctly, is it possible to run the installed VMRC in OpenNebula 6.0? Yes, absolutely. You can definitely use it as it's implemented within Sandstone. It may be that maybe you don't. You also have the same problem. It doesn't recognize the keyboard layout correctly, but you can define the key map from within Sandstone, and maybe that helps. If it doesn't, please let us know using the forum. the link in case you don't know it. Yeah, and we'll be happy to help. Okay, some more questions. Alberto, do you have any other questions I may not know the answer to?
Even I knew the answer. Well, let's just go back to the, just a reminder for people that want to actually give it a try. And just a reminder about the both the landing page we prepared with all details about the new release, and then the guides, that the quick start guides that we prepare as part of the new documentation, and you can access that through that landing page. So it's very easy to actually try this, deploy Stina mentioned an OpenNebula front end and, on KVM or on your VMware infrastructure, and then from that front end to deploy other resources somewhere else or on your infrastructure, and try the rest of the new features in the release. Okay, there's a question now. What is the team focusing on for the next 12 months now that we have K3S on 6.0? Okay, so roadmap.
Quite a question. 12 months.
With or without another pandemic?
Just one thing for K3S, we will update the appliance. So this is something that we are doing, with Sebastian full stack, in order to auto-register to Ranger. So if you have a Ranger installation when we are going to update the appliance, you can pass some information about Ranger, and then the K3S cluster will auto-register. And so then you can, for example, use, instead of kubectl, you can use Ranger to deploy a application on multiple clusters, or using Fleet. There's something that we are going to release in the next weeks.
Yeah, there's actually this very interesting that now that Marco mentions that, we'll announce that properly in a few days' time, but there is a nice joint talk that we'll have with people from one of our partners from FullStacks and on SUSECon, and that's exactly what Marco mentioned. So this auto-registration of the K3S, so deployments of K3S at scale using OpenNebula, and then these K3S clusters auto-register on Rancher. So that's a very interesting use case. But then, I mean, in terms of apart from improving a number of features, one of the main things that we already mentioned is we're going to be working to expand that catalog of cloud and edge providers. So the idea here is to offer users as many options as possible for them to be able to forget all the complexities in that kind of underlying level, and consolidate OpenNebula as something that they can use to actually avoid that kind of vendor locking that we all know about. So in that sense, we're working now on a couple of new drivers. We're also in contact with other vendors to populate this catalog and make it as useful as possible. And then obviously as well edge providers, including a number of telcos. So OpenNebula users will be able to deploy edge clusters on 5G edge resources, and that's actually something very, very interesting.
Yeah. So yeah, we basically just we released 6.0 last week, and we are now in the process of defining the roadmap for the next release. In fact, for the next few releases of the 6 series. So we'll be publishing a post probably in the next few weeks detailing the roadmap. Okay, but a big focus is going to be definitely to build or enhance increase the number of public cloud providers that you can create these clusters as a service on. So this catalog at the moment has Amazon EC2 and Equinix. That's what you get in OpenNebula 6.0 if you install it today. We are working on a number of new additions. Next ones in line are going to be Google Cloud and also Microsoft Azure. But one of the big focus on the next year or the next 12 months, it's going to be around this provider catalog and many other aspects that will be defining in the next few weeks. We'll make an announcement regarding the roadmap.
Okay. Then there's a final question on the new reference architecture guide and if there's a new reference architecture guide for OpenNebula 6.0. And yeah, I mean the answer is yes to that. So if you get to the landing page as well, and you'll see some references to all the links to the documentation. And then on the home page, you've got a link to the Edge Cloud architecture, and then you've got some more details in there. So yep. Okay, so I think that's an hour and a quarter. I think we can call it a day. And, well, thank you again, everyone, for joining us, and give it a try and keep in touch. Use our community forum. Let us know how you are using the new OpenNebula, and then keep tuned for the novelties that are to come. Okay, take care and see you soon at the next event. Thank you all.
Thanks for coming.
Bye.
Have a nice day. Bye-bye.